All right, so what we're going to do today is we're going to look at something called ratios. Now, a ratio is just a comparison of numbers, okay? So a ratio simply means a comparison, and remember, if I write it down, that means you should be, of numbers. You do this all the time, right? Okay? Well, maybe you don't do it as much, but life does this all the time. So say, for example, when you're talking about the speed of a car, right? Okay? When a car is driving down the road, you measure that in what? Kilometers per hour. I would have said miles too. Kilometers per hour, right? Right? That is an example of a ratio. And there are all kinds of ratios. Tons of different types of ratios that you could write. And so we're going to be looking at them and how to use them. Okay? And some of the basic ideas of them. Notice that this ratio I've written as a fraction. There are other ways of writing a ratio. More frequently, ratios are written with a colon between them. Okay? Or you can also see it as kilometers per hour. You see that word per? That always means you're doing a comparison. Or a ratio. Okay? Pardon me? Per, yeah, that's just the word per hour, yeah. Yeah. All right, so let's look at our Education Perfect so that we can go through some examples. Okay, so here we go. So we're going to learn about ratios. And ratios were originally developed to describe things that are happening in geometry. So if you look at this, as the small circle spins, how many times does that red dot hit the blue line of the big circle? 3 times. That means that the bigger circle is 3 times bigger than the smaller one. Pretty cool, huh? So you could see, so just by spinning it, you could see. Now, it's a little difficult to spin a circle like that to be able to tell. But that's an example of a ratio. And that's where ratios were originally started with geometry. Notice that it doesn't matter if it's on the inside or on the outside. The ratio stays the same. Now, you are not going to be working with the geometric ones. It's just a cool visual that they're giving you. So don't think this is what you're going to be doing. Okay? All right. So we're going to learn first about what are called equivalent ratios. And we've talked about the word equivalent before. What does equivalent mean? The same. Does that mean they have to look the same? No, but they have to have the same value. Right? Okay? Yes?
Quick question. Will we be doing a practice test before we do the real test?
Absolutely. Mm-hmm. All right? So we're going to be looking at equivalent ratios and how they can help us solve problems. Okay? So, all right? Finally, we're going to look at how ratios, fractions, and percentages all relate to each other. So these are the things we've been talking about, fractions and percentages, right? So now we're going to pull them together and put ratios in there, and those are the 3 things that all go together. And again, you are not going to have to do this geometry. They're just trying to keep you interested. Sometimes a kitten might be more appropriate because the geometry like that is kind of freaky looking, yeah? But, okay? All right. You won't have to do that. Okay, so here we go. This is a ratio. A ratio is simply a way of comparing the size of 2 or more quantities. Okay? So you look here, we have these 4 boxes, A, B, C, D. Okay? We write ratios as numbers separated in the following way. So this one is 2, 3, 1, separated by colons. That's how you know that it's a ratio. You will not see that type of notation anywhere unless it's a ratio. Okay? So, how can I tell this is a ratio? Because of the colons. Right? And you often hear these as written as the word 2 as well. 3 to 1, 2 to 3, or 2 out of 3. So out of is another way of saying it. Okay? Per. Lots of different words for ratios. And we're going to look at examples of using them all. So, okay, all right. And we're going to learn a little bit about some of the pieces of ratios and what's important about them. So in this animation, the large circle is exactly 3 times the circumference of the small circle. In other words, 3 times means 3 times what? Bigger, exactly. And we can tell that using geometry because when we spin it around, it touches it 3 times. But if you want to talk about it as a ratio, the ratio of this is 3 to 1. Now, it's important that you know which one's which. The 3 is which one? The large one, and the 1 is the small one. And that's probably the most difficult part of ratios. Knowing which one's which and making sure that you label them with their units. And so we rarely write a ratio without including the words. Now, when you write it with the semicolon, it almost never includes words or units. But when you'll see later, we're going to write them in a different format, and it always includes the words or units. So that makes it a little easier for you. And that's the way you're going to use them. All right? Okay. So it's really important to get them right. So say we have a classroom with 9 girls and 8 boys. Then the ratio of girls to boys. Now again, when you're doing a ratio, this is girls to what?
Boys.
So that means that the girls is going to go when? First. So there's 9 girls. Imagine that girl's going first. And then 8 boys. So the ratio 9 to 8. Yes?
So if it's in the problem, 8 boys and then it's 9 girls, it would still be 9 to 8.
Well, this is the part. They could reverse the numbers, but that's the part. Give us the ratio of girls to boys. Now, what if they had said boys to girls?
9.
Yeah, then you would reverse them. So it's not really the numbers that tell you what order they go in. It's the ratio, the comparison. Good question. That's an excellent question. Because I could say the ratio of pencils to pens, and you know it's the number of pencils on top of the number of pens, right? But then I could tell you that I have 5 pens and 6 pencils. So you can reverse the numbers can come out in any order. But you've got to make sure you pay attention to the wording of the ratio so you know which one to put where. Excellent question. Thank you for that. Okay? All right. So, you need to make sure that you're careful about the orders and the categories in the same one. So girls to boys is 9 to 8. The ratio of boys to girls, however, would be what? 8 to 9. We did that one we were ahead of them. So here we go. A mixed tin of biscuits contains 7 chocolate chip cookies, 5 digestive biscuits, and 8 shortbread biscuits. Write a ratio showing the abundances of the different types of biscuits. Okay? Now, are they telling us what order to put them in? Nope. So let's just put them in the order they give them to us. Okay? So I'm going to write a ratio. How many chocolate chip do I have? 7. How many digestive? 5. How many shortbread? 8. If they don't give you an order, just put them in the order they give them to you, right? But what if they had asked you to do shortbread to chocolate chip to digestive? Then shortbread would be 8, chocolate chip would be 7, digestive would be 5, right? So if they tell you an order, you use their order. If they don't tell you an order, just string them out in the order they give them to you. Okay? Make sense?
Yes.
Good deal. See, I told you this was easy. How easy is life today, huh?
Very easy.
Good. There we go. 7, 5, 8. Chocolate chip to digestive to shortbread. Okay? Sometimes you're going to need a ratio and in order to make categories that aren't so neatly divided. So you need to make categories in order to be able to create your ratios. So we're going to look at how to do that really quickly. So we have a pile of jelly beans with 16 red, 12 yellow, and 17 green. So those numbers are very important, right? 16 red, 12 yellow, and 17 greens. We want to find a ratio of jelly beans to the other colors in order to... So if you want to find the ratio of red jelly beans to the others, red to all others, right? So in this case, I'm only comparing one color, but how many other colors were there? Two. Yes.
So isn't it 16?
Right, so you're just going to, we know how many red there are. How many red are there? But we have yellow and green. So what am I going to need to do in order to find those? Simply add them together. So in some cases, you might have to add one to get the other category. So we wanted specifically red. We had a number for that. But we wanted then all the other ones that we knew. So all the other ones means get a total, right? So that means add them together. Okay? How does that look to you? Easy. Good. I love it when you like easy. All right. Oops, that's your homework. I'm not doing that for you. Let's go here to equivalent ratios. All right. Now, since ratios show the relative sizes of quantities, there's more than one way to write every ratio. Now, this is a little odd because if it says more than one way, then that seems like you need to write it in a different format, right? But what they mean is that you can write it using different numbers, right? The numbers that you get are not always going to be the ones that you're going to use. Yes?
You mean that was
There you go. Exactly. Okay? So, what we're going to do is, what you're going to see is ratios, just like fractions, must be simplified. Okay? So let's write that down. Ratios, just like fractions, must be simplified. And I want you to underline must, please.
Must.
Yeah, but you betcha. Okay? And that simply means divide out any common, remember the word? Factors. There you go. Thank you so much for that. That's wonderful. Factors. Any number that will divide evenly, but it has to divide evenly into how many of the numbers? All of them. So if you only have two, it has to divide into both of them. But if you have three, it has to divide into all three. Yes, ma'am.
So do you always simplify it into like the other ones?
Sorry, ladies. Shh. What?
Do you always simplify it instead of saying not to simplify?
Yes, so you just always simplify, always, every ratio.
Unless the question said please don't simplify it.
Unless they tell you specifically not to. Yes, you will simplify. There are going to be times when you might build up a ratio. And we'll look at some of those perhaps in this section. I'm not quite sure. But you might build up a ratio to change the numbers. But as a general rule, if you're writing an answer, the simplified form is the one you want. Okay? Unless they specifically tell you not to, then that's what you need to do. So if you look at this one, they had 3, 9, and 6. Those would all divide by 3, so that's what they did. 3 divided by itself gave you the 1. 9 divided by 3 gave you the 3. 6 divided by 3 gave you the 2. Okay? So just find the number that will divide evenly into all of them. Okay. Now, did I show you the upside down division thing? No? Okay. Well, we'll deal with it later then. All right. Okay. Here we go. So in the animation below, the smaller gear has 8 teeth and the larger gear has 16 teeth. This means that the small gear rotates 16 times for every 8 rotation of the larger one. All right? So the smaller one is going to go faster because it's smaller, right? The ratio of the number of rotations to the small gear to the large gear is 16 to 8, right? That's the small one versus the large one. And again, they're talking about the rotations, not the number of teeth, okay? Even though it happens to be the same in this case, right? So the number of teeth and the ratio. So simplify this ratio. Well, what number will divide evenly into 16 and 8 at the same time? They'll both divide by 8, won't they? Think the biggest number possible. Now, if you divided them by 2, that would work, but notice what happens. You could do it again, right? Okay? Or you could see that they'll both divide by 4. Now, it doesn't matter how many times it takes you to get there. The important thing is to get get it simplified all the way. So if you like to, you can divide them by 2 all the way down. It'll take a little longer, but is it about speed? Nope. It's about accuracy and getting the right numbers. Okay? So break them down the way you see them. Is everyone going to always do them exactly the same way every time? No way. Does that make it wrong? No way. Okay? So if you saw 8, then you could get to the 2 to 1 immediately. If you saw 4 or 2 or something, it might take you a few more tries, but that's fine. Yes, good. Doesn't matter. What matters is you. Do you divide bigger numbers well? Then use the bigger numbers. Or are your division skills a little shaky? Then use the smaller numbers. Right? You do what makes you comfortable. Okay? Excellent. Okay, so we simplified the ratio. Let's see if we got it right. There we go. The small gear will rotate 2 times for every rotation of the large gear. Oh, for every rotation? Well, we had 2 to 1. But they don't say 1 rotation. They just say rotation. Where's my 1? Right. What is this?
It's a pen.
A pen. Do you say 1 pen? Nope. If you name an object, then you assume how many? 1. So, a chair, not 1 chair. Right? A student, not 1 student. Yes?
It's like in algebra, if you don't necessarily use 1A, you just put A.
Exactly. So, if you have an object, you don't have to put a number. You don't have to put a number if you just mean one of them. But that's a huge idea in mathematics, and especially with ratios. So if I say the ratios of 4 students to a teacher, that's 4 students to how many teachers? 1 teacher, right? So be careful. If they just give you the name of an item, that means there are how many? Okay? All right. That's an excellent example we need. Okay? You can also multiply a ratio by a common factor to get a ratio with larger numbers. And this is what I was talking about a while ago. As long as we keep it equivalent, equal, then we're fine. So, if I'm going to do that, I can multiply by anything I want to. But if I multiply the first number by, say, 5, what does that tell me? I have to multiply the second one by what? 5. So you can make it bigger as well by multiplying things. But if you multiply one of them by something, to keep them equivalent, you must multiply them all by exactly the same number. Okay? So you must multiply, just like we did with the division, by the same factor. Okay? So, and could I, if I had 3 numbers in my ratio, could I multiply 2 of them and not the third one? No, you'd have to multiply every single one of them. Okay? Now, all right, so let's look at an example of this. Now, we already know that small gear rotates 16 times for every 8 rotation of the large one, right? So our ratio for our gears is 16 to 8. How many times does a small gear rotate if the large gear rotates 32 times? Okay? So, we have I don't know why I'm on a line drawing tool. Okay? We have a ratio of 16 to 8. Now, be careful. You might be tempted. So what we did is we want to know how many times the small gear goes. If the large gear rotates 32 times. So be careful which thing you're basing the numbers on. Okay? So what we're going to do is we're going to simply multiply, but we're going to multiply something to get that ratio, but we have to keep the ratio the same. Okay? So first, we need to see what number we need to multiply the large number of gear rotations by to get 32. Okay? Since the original ratio, the 8 has 8 large gear rotations. That's not correct, is it? Yeah, that we was small to large. Okay, never mind. I'm sorry. So 8 large. The factor we need is 32. The factor we need is 4. So what you need to do is simply take the new number you want and divide it by the number you have, and that will give you your multiplier. You may not. Okay. Okay? So, but if I multiply one of them by 4, then what? I have to multiply the other one by 4. So my original ratio, right? I want to turn that 8 into 32. So what did I multiply 8 by to get it to 32? 4. So that means I have to multiply the 16 by 4 as well, which gives me 64. Okay? And that works like that every time. So if you'll just simply put the ratios one on top of the other, the original one, put the new number down, and then just take the new one divided by the old one, and that will give you your multiplier. And then multiply the other ratio by that multiplier. Right, so it's just a simple matter of dividing. Okay? This is the same thing you would do when you're looking to get a common denominator for fractions. Do you remember that? Getting a common denominator for fractions? We haven't done any addition or subtraction with fractions in this class. But, okay? All right. So there you're going to have some where you're writing in simplest forms. Okay? All right. So far, so good? Pretty easy? All right. Sorry? Mm-hmm. All right. Now, since ratios are relative sizes of quantities, they're closely related to fractions because remember, a fraction gives you a rate is really a ratio of the number of parts to the whole. In other words, how many total parts are there? And we have this many of them. So if you have half a pie, you have 1 out of the 2 pieces of pie, right? The whole thing is cut into 2 pieces, and you have 1 of them. So that's a type of ratio. So and so you can be able to write a ratio as a fraction, but you have to be careful. You don't just put the one number of the ratio on top of the other one. That's not going to work. Because remember, the bottom part of a fraction is always the total number. And what operation comes to mind when you think of a total? What operation? Your addition, right? You're adding them together to get a total, right? To get a sum. Okay? So we can write it as sum, since we know that sum means the answer when you add, right? So that means to get the total, what do you think I'm going to have to do to the 2 pieces of the proportion? Add them together, exactly. Plus them, add them together. Good job. So we could write it as a fraction, but you have to be careful and get the total. So the ratio of A to B, okay, first of all, you need to know which one you want to put on top. So you're going to write one fraction out of that, but it's part of them. So, for example, if I want to write a fraction representing the ratio of A, then that means the A is going to be my top number, and then A plus B is going to be my bottom number. my denominator. Okay? So you have to add them together. Okay? So say we have the ratio of A to B. We can write fractions corresponding to A and B by putting them on top of the fractions. So the first one represents the ratio using A. The second one represents the ratio using B. Notice it makes two different fractions, right? But what's the same about them? The bottom number, the denominators, are going to be the same. Okay? All right. So, a pet lover has cats, dogs, and ferrets in a ratio of 5, 3, and 1. What fraction of the pets are cats? Okay? So, cats is which number? 5. The first number. So we know there are 5 cats. Might as well write it under the cat. Out of how many animals?
9.
Yeah, 5 plus 3 plus 1, which is 9. So 5 out of the 9 cats, 5/9 of the pets, are cats. Okay? All right. You like these better than the circles? Okay. Yeah, I figured you would. All right. Less scary. All right, so there you go. Simply add them to get the denominator and then put the right numerator. Make sure you're using the right one, though, right? If it had been ferrets, we wouldn't have used 5 on the top. We would have used 1. Okay? You can also turn fractions into a ratio. You just have to make sure that the bottoms of the fractions are all the same. Then the tops of the fractions become the ratio. All right? So all of the numbers on the bottom have to be the same of the fractions. So here, she empties her piggy bank. She finds that she has 2/7 gold coins and 5/7, guys, silver coins. Okay? So I can write a ratio of that as long as the denominators are the what?
Same.
And are they the same already? Yes. So to write the ratio, all I need then are the what? The top numbers, the numerators. So it's going to be simply 2 to what? 2 to 5. Okay? Writing it as gold to silver. Pardon me?
Does the two numerators have to add up to 7?
Yes. Or else it's not a ratio. Okay? So all you need to do is make sure that the denominators are the same and then write the numerators as your ratio. So therefore 2 to 5. Okay? So you're going to have a little bit of work doing that. Hold on. We're almost there, kids. It's easy, but there's a lot of it. Okay? But, all right. So, as well as fractions, they're also related to percentages, because remember we can turn a fraction into a what? Percent. Remember, that's what we spent. It's one reason why we're doing this in a hurry, because we spent 3 days doing that. All right. Now, so if you have 40%, remember, percent means simply divide by what? 100. So any number, any percent can be written by a fraction simply by putting it over what? 100, because 40 over 100 means divide by 100. Okay? Do you remember that? Divide, so to turn so the percent means divide by what? 100. Okay? So, in solutions where they're using a ratio being divided up, we can just use percentages to write a ratio. So 25%, 45%, 30%. Okay, whoops. All right. Oh, they're going to give it to us in the form of a question. So Brandon and Cameron buy a large bucket of popcorn to share during a movie. Okay. Alice eats 30%, Brandon eats 15%, and Cameron eats 55%. What is the ratio? Okay. What is the ratio for the amount Alice to Brendan to Cameron? Get them in the right order, but they're in the right order, right? Well, Alice is 30%. How do I write that as a fraction? 30 over what? 100. Okay. And then Brandon is 15 out of what? And then Cameron is out of 100. So that gives me, do they all have the same denominator?
Yes.
Yep. So that gives me the ratio 30 to 15 to 55, and I'm done, yeah?
Oh, couldn't you just take the percentage
It's so
sign
big.
off?
He ate over half.
Yeah, that's what the divide by 100 means. The percentage. What's wrong with it? Well, hold on a minute. We're not finished with this one yet. What's wrong with this? 30, 15, 55. There you go. They'll all simplify. They all end in 5 or 0, so we know they'll divide by what?
5.
At least 5. So let's divide them all by 5, which gives us 6 and 3 and 11. Anything will divide into 6, 3, and 11 at the same time? Nope. So that's our answer. Don't forget to simplify it. Okay? You guys, y'all were so calm. Well, you're going to have some homework where you simplify ratios. So there it is. So that it's each 1 over 100, and then 6, 3, and 11. Because you must simplify them. Yeah? Okay. So, yes, but you don't want to simplify it then because the denominators wouldn't be the same. So don't simplify them when the denominators are the same. Simplify them after you create the ratio. Because if you divided them all, then what the numbers on the bottom would change. Yes. Okay. All right. You can also turn a ratio into a set of percentages. Okay. All you need to know is first we turn it into a set of fractions, and then you just turn each fraction into a percent, just like we did before. So how do I turn a ratio into a fraction? Use the number as the numerator, and then add them together to get the denominator, right? And then I can change that into a percent by multiplying it by 100, right? And then that'll give you your percent. Yes?
Wait, could you write those 6 stats?
Yep, I certainly will. So let's see. Okay, so first, put each part of the ratio as a numerator, right? Capital N, we always say is numerator. Second, add to get the denominator, right? You just add all the numbers up to get the denominator. And then multiply that fraction by what to change it into its percent? By 100. And finally, add the percent symbol with the lines not connected, because I know how picky y'all are. Okay? So what percentage of the mail consists of postcards? So we're only interested in postcards. Which is the first one? Nope. Second one? Nope. What? Third one. So that number is what? 3. Over. Now how do I get the denominator? Add them all together. 6 plus 1 is 7, plus 3 gives me 10. Right? Now, we need to multiply that by what? 100. And remember, when you're taking a fraction of a number, you divide by the bottom and then multiply what's left times the top. This will be on the assessment for sure. So it's 100 divided by 10 is what? 10. And 10 times 3 is 30. So how many of them, what percentage of them were postcards? 30%. So this part is not new. Right? The only part that's new is this building the fraction out of a ratio. Okay? And if you don't understand what I just did with that divide then multiply thing, then you're in trouble. We need to fix it before next week. Okay? So, take this number, divided by this number, gives you your multiplier. Multiply that times the numerator, and that'll give you your percent, right? Make sure you also Put in your percent symbol. Yes? Yeah.
I would want to put in my homework, but I think I would have to.
Yes. Well, it'll all be on the recording too, but hurry, quickly. All right, because I need to push next. All right. Now, let's see what's next. Oh my gosh, I got it. All right, that's it. So now share it if you want to. Okay. Okay. Now, they're gonna do it. They're gonna put it on here too. So it's gonna be on your Education Perfect. All right. Okay. Then goes into your homework. So there you go. So we've talked about what ratios look like, the fact that you always have to simplify them. Equivalent ratios just means simplifying them. One ratio equals the other. They look different, but they're the same. We talked about how to turn a ratio into a fraction by simply adding up the numbers to get a denominator. Then we change those into percentages. Did a lot, but it's related. Pardon me?
There's another slide.
It's just a summary. Yeah. So I just did it. Okay? All right. So you have a homework assignment up based on this. It's already assigned to you and should be ready to go when you can work on it now, but we're almost finished, yeah?